Go ahead and get that going just so that everybody who wasn't able to come at this time can see what we're doing. And see if I can get this to stop annotating. That would be great. There we go. All right, so I have a few things that I know I want to go over. And was there anything else, Shawana, that specifically that you wanted to talk about? Any other things?
No, because I pretty much like with the way they do it. I understand the equation and doing
Okay.
just to enter it into the calculator part.
Okay, great. Okay, yeah. So hopefully that clears that up. I just wish they didn't have that in parentheses. The whole things you're supposed to enter into the calculator. You really just want to have one value. So let me ask before I get started. This was one of the questions that I was going to do. I hope everybody can see that. I'm starting to wonder because my screen has changed. Okay, everything. All right, let me see. Go back to this. Okay, can somebody let me know if they can see this screen that says an entrepreneur invest in a new play? Not sure if that's showing up for people.
I can see it. It's just the writing is just very small.
Okay, so I can just want to make sure that was showing up.
Imari in the chat said he can't see it, or she. I'm not sure.
Let's see if I can open the chat. It's not showing me very much. Okay. Get these crazy things off the screen. All right. Oh, you can't. Okay, they said they can see it. Okay. Finally got that pulled up. Okay. All right. So, okay, if everybody can see it, we'll look at this. So I'm going to start with this one because this is one that people ask about a lot. And so I basically want to go through several questions that I know people ask a lot of questions about every semester. And then if anybody has any specific questions, please speak up. I'll work through any specific questions that you want to work through. But unless anybody asks for specific stuff, I'm just going to work through the things that I know people typically have questions about in the homework and the quiz. So this says an entrepreneur invests in a new play, and the cost includes an overhead of $37,975 plus production costs of $2,100 per performance. Let me get this to all fit on the screen. And that keeps moving over. Nuts. Stay. A sold out performance. I know you can't see the side of that, but it's going to say it brings in, or it makes them the amount of $2,875. Okay, so they make, or they bring in a revenue of $2,875 for a sold out performance. And then it asks you for all of these different things. Okay, so they're giving you the cost, overall cost of $37,975, and then an additional cost of $2,100 per performance. And then they're going to tell you how much you're going to make per sold out performance. And it says to let X represent the number of sold out performances. So this is going to drive me nuts. This thing just will not stay in one spot. Okay, so it asks you for the cost function C. So the cost is literally your total cost, which we know is $37,975 plus $2,100 times the number of performances that you have. And since X is the number of performances that you have, it's 2,100X. So the cost is just $37,975 plus 2,100X. Because you've got, this is a fixed cost, the $37,975. You're going to spend that much no matter how many performances you have. And then you're also going to spend $2,100 for every performance you have. And then the revenue is $2,875 times the number of sold out performances you have, because it tells you that you will have, or you will bring in $2,875 for each performance. So then the break even point, there are lots of questions in, I think it's section 7.3. Section 7.3 that asks you to find the break even point. The break even point just means where are you not going to lose any money, but where are you not going to also make any money. So you don't lose anything, but you also don't make any kind of profit at all. This is just, where does your cost equal, where does your cost equal your revenue? So you're not making a profit, you're just breaking even. So basically, you just set those two things equal to each other and solve for X. Okay, so where does your cost equal your revenue? Where are those two things the same? So going back to one of the first things you learn when you take algebra, you can subtract 2,100X from both sides. So take 2,100X, subtract that from 2,875X. So if we take 2,875X, I'm going to write this up here just to get it out of the way, and subtract 2,100X, we are left with 775X. So then how to solve for X? We just divide both sides by 775. So we're taking 37,975 and dividing it by 775. And so we get 49. So if X is 49, we got to remember what X means. Remember from the question that X represents the number of sold out performances. Okay, and typically when they ask you for the break-even point, they want an ordered pair. So far, all we have is an X. We don't have a Y. Okay, so this 49 is the X value in our ordered pair. So for part C, we know that 49 is the first number we're looking for, the X value, but we have to figure out what the Y value is. Well, remember, this is a break-even point. This is where the cost, this function, and the revenue, this function, are the same. So it doesn't matter which one of those you plug the 49 back into. So you can plug in X equals 49 into either one of those equations and you should get the same answer. I'm just going to use the easier one, which is the 2875X, because if I plug in 49 into that, I don't have as much to type into my calculator. So if I plug in 2875 times 49, that gives me 140,875. So this is what I'm going to put for part C, 49, comma, 140,875. And make sure those are in parentheses because it's asking for an ordered pair. So MyLab Math is not going to understand that you're trying to type it in ordered pair if you don't put it in parentheses. And also note that it says don't use commas for large numbers. That's because you've got to have the comma to separate the X value and the Y value. So if you put another comma here, it's not going to understand what's going on. So leave out the commas. Just erase that. 140,875. So don't put that comma in because that's going to make it confused. So leave your commas for separating your X and Y value there. Okay, so then it says, what does the break-even point mean? Well, the break-even point does not indicate a loss and it does not indicate a gain. It indicates where the cost and the revenue are the same, where you're not making a profit at all. So it means that for 49 sold out performances, because remember we found out that X was 49, so for 49 sold out performances, both the cost and the revenue are $140,875. So every time you're asked to find a break-even point, you're being asked to set the cost and the revenue function equal to each other and solve for X. Wanted to do this question. Now, does anybody have any questions about that one that they want to speak up and ask before I do a different type of question here? Okay. Okay, I'm hearing somebody that's unmuted. Did you have a question? not sure what that is.
I think it's Lanisha Allen. She's not.
Okay, good. Yeah, let me see if I can mute. Okay, there we go. Okay, Lanisha, did you have a question? Okay. All right, so let's look at this from section 7.6. This is a very frequently asked question, and you're given a bar graph of the average room and board at public versus private colleges. From selected years 2011 to 2017. So that's your x-axis. You've got the various years. And it's telling you already, it's not asking you to type in any data into the calculator. It's just telling you that here are two models for the data. There is a linear model. The f of x equals 963x plus 3010. And then there's this exponential model. So they're calling that g of x equals 3,877 e to the 0.133x power. Now, they're not asking you to come up with those. They're not asking you to even necessarily say which one is better. They're just telling you, here are two potential models for this data. And then here's the real data on the right in the bar graph. So the first thing I want to do so that I can write on this is move this over to this other program so that we can. Okay. So the first question says, according to the linear model, what's the average cost of room and board at a public 4-year college in a school year ending in 2013? Okay. So looking at the graph, first of all, we've got to know, what does X represent? Okay, so X represents X years after 2010. X years after 2010. That means in 2011, X equals 1. In 2013, X equals 3, because that's 3 years after 2010. In 2015, X equals 5, because that's 5 years after 2010, and so on and so forth. So what does it mean by linear model? Linear model means which one of these is a line? Well, definitely we know that this is a line because it's in, just basic slope-intercept form. So if we have that line and we plug in the value of X for 2013, well, for 2013, that's 3 years after 2010, so X equals 3. So we're going to take this line, 963X, and X is 3, because that's 2013, plus 3010. And that's going to give us, whatever that gives us, 963 times 3 plus 3010. So according to the linear model, the average cost in 2013 was $5,899. Okay, what about according to the exponential model? The exponential model is this right here. So according to the exponential model, the one that says 3,877 times e to the 0.133x, and remember, again, we're plugging in 3 for x. We're plugging in 3 for x because we're talking about the year 2013, and the year 2013 is 3 years after 2010. So you may not have ever used E on your calculator before. Strongly encourage you to make sure you read this section in the textbook, just like you should be reading every section in the textbook, because that is what's going to introduce you to what E even means. We also have lots of videos, and we've got PowerPoints in iCollege to introduce you to the concept of what you're learning in this section. I'm doing this more just to show you how to do frequently asked questions, not to give you all of the background information on everything, because otherwise we'd be here for 4 or 5 hours. But definitely read section 7.6, look at all of the examples, look at the PowerPoints, look at everything. So how do you type this into the calculator? 3877 times, okay, so where is E? E, you have to hit the second key on your calculator and the LN button. So just to the left of the number 4, you should see the LN button. So if you hit the second function and then LN, the E to the X button is above that LN key. So 3877 times E to the 0.133 times 3. So that's what that looks like when you type it in. And that gives you 5788, back on the screen, 5788.023439. Okay, but it said round to the nearest dollar. Okay, so to the nearest dollar, that's just 5788. Because this next digit is a 0, so we round down. So, which model is better? Well, how do we know that? What does that even mean by which model is better? Well, we know which model is better based on which one is closer to the actual data that was given to us in this bar graph. Okay, so if we look at the bar graph, in 2013, what was the actual data? Now, which color are we looking at? This was for public four-year colleges. So we're looking at the green bar graphs, not the orange or red or whatever color that is. So in 2013, the green bar graph said it was 5,146. So that's the actual data. That's the actual cost for public colleges. So let's compare it. Which one is closer? Is 58.99 closer to 51.46, or is 57.78 closer to 51.46? Well, 57.78 is closer by around $100 or so. So in this case, it looks like the exponential model did a better job of modeling this. Go back to, so we choose the exponential model is better. And that's it. Okay, this is another question that gets asked a lot. I also want to screenshot this one and talk about it. Now, before I even look at this, I want to make sure that, again, and this is all in your textbook in section 7.6, and that's why it's so important for you to look at the textbook, for you to watch the videos in iCollege, and for you to look at the PowerPoint notes in iCollege. But it's very important that you know these basic shapes of functions, because once you plot these points in MyLab Math, the only way for you to figure out which type of function you need to use is for you to know these shapes, to know what they basically look like. Now, we all know what a line looks like, obviously. Doesn't necessarily have to look exactly like this. It could have a negative slope instead of a positive slope. And then when you use a quadratic function, that means it looks like a parabola. So it goes down and then goes back up. Or it could be flipped over. Imagine it being flipped upside down. It could go up and then back down. But one or the other, it either goes down and then back up or up and then back down. That's how you know to use a quadratic. How do you know to use an exponential function? Well, if the data does this, if it looks like this graph, has that shape somewhere on the graph, and then logarithmic graphs have this shape. So based on what the okay, sorry, I just saw these in the chat. Questions later on that. Okay, good. Okay. So you'll look at what the data does, and you'll pick one of these four types based on the data. Okay, so this one, fortunately, because in some of these, they make you make the scatter plot yourself. And if you've done any of the homework, I'm sure you've seen how you have to take the little dot and put it in just the right spot, and you have to do that for every single point, and then you have to look at the shape. And that gets a little bit time consuming. But in this case, they are actually giving you the scatter plot right here. Okay, so do you see the shape that this is making? Put this on the other screen so that we can keep looking at it. Okay, so look at the shape that this is making overall. It's kind of doing this, right? And based on what we said about that, that looks like a logarithmic function. Okay, do you see that shape of this logarithmic function? It looks very similar to the shape that we're being shown in that scatter plot. So why are we using a logarithmic function? It is because the data increased rapidly and then began to level off like that. Okay, it's not continuing to go up. It's not making a line. It's not going down and then back up, or up and then back down like a quadratic would. No, it's increasing and then starting to level off. So that is the logarithmic function. Okay. Now it says using the graphing calculator screen, express the model in function notation. In other words, based on this, you don't have to do anything. You don't have to calculate anything. You don't have to type anything into the calculator. They're giving you the output. They're telling you what the calculator has already done and what it has told you. So the calculator's telling you for y equals a plus b ln x, this is what a equals, and this is what b equals. So you just fill in that value for a and fill in that value for b. And it says to round to the nearest whole number. Okay, so trying to make sure that this is still recording. I just got some kind of a message that it might not be recording anymore. It's not good. Gotta double check that because I know some people are counting on that. Okay, it has completely disappeared, so let me see. I'm sorry. Well, I have to hope that it's recording because I cannot seem to find it anywhere. All right, so round to the nearest whole number. So A is 29.945. So rounded to the nearest whole number, that's 30. And B is 29.892. And rounded to the nearest whole number, that is also 30. Just a coincidence, and definitely not always going to be the same number. So this is all they're asking for when they ask for that equation. 30 plus 30 ln x. Now when you type this into MyLab Math, 30 plus 30 ln x, please keep in mind that is lowercase l, lowercase n. And you don't need any kind of special symbol to type that in. You literally just, I put it in capital just so you could see what the letters were. You don't want to use capitals. But you just type in lowercase l, lowercase n, don't put a space or anything, and you'll notice that MyLab Math will automatically put that in bold, and that's just to indicate that that's a function called the natural log, and you don't have to do anything special. You just type in ln. And then the last part of the question is, according to the model in part B, what percentage of an adult-sized brain does a child have at age 10? Well, in this case, our X values are literally the kids' ages from ages 1 to 11. So we're literally just plugging in X equals 10 into this equation. So when we plug in X equals 10, let me show you how to do that in your calculator. So 30 plus 30 ln x, and we're going to plug in X equals 10. 30 plus 30. There's the LN key. It's just to the left of the number 4. And then we put in 10 for X. So the calculator gives us 99.07755, blah, blah, blah. So we don't need all those decimal places because the instructions said to round to the nearest whole number again. So we just round that to 99. So according to the model, a child has 99% of their adult brain at age 10. So the question is, how close is that to the actual data? Does it overestimate the data or does it underestimate the actual data? So let's look at the table. According to the table, a 10-year-old has 96% of their adult size brain. So our model was too high. So we overestimated, our model overestimated reality, or the data that we have anyway, by 3%. Because we said at age 10 it would be 99%. The real data said at age 10 it would be 96%, so we overestimated by 3%. So I hope that helps clear that one up. And also remembering the shapes of those functions is really important. Also, some people tend to have a issue with just plotting these points on the in MyLab Math. So just remember that you have to do each one separately. So to plot 0, -6, you literally have to drag this to 0, -6 and hit check answer. And then you have to do the next one. You have to drag it to 1, -5, and then hit check answer. And you have to do that for each one of these. So as annoying as this is, I'm going to do it really quick to show you that it's going to make some kind of a shape. 1 and 4, 9. Nope. And sometimes, at least I found on mine, I would get it to where I wanted it, and then it would just move right before I would hit check answer. It would just move itself. So don't get too frustrated. Just keep trying to get it snapped to where it's supposed to be. So you see how this is making the shape. So you have to figure out what shape is this? What do I need to use? Does that look like a line? Does that look like a parabola? Does it look exponential or does it look logarithmic? So that could be exponential. Looks like it is, just based on those shapes. So you got several questions like that. And then I definitely wanted to work through in section 12.6, wanted to work through getting these answers. There's a lot of data you have to work with in 12.6. You have to put in You have to put data into the calculator and get it to calculate the value of R for you. So let's work through one of those from the homework. All these windows in my way, and I can't click on what I need to click on. Okay. So in this type of question in 12.6, they're just asking you to, which one of these graphs has this data plotted? So I'm not going to take the time to do that, but in other words, which one of these graphs has these points, 22, 17, 20, 12, 41, 3, 4, 33. So you just have to look at each one and figure out which graph has this data on it, and then do they appear related? This section is all linear. So in other words, do they make a line? Does the data make a pretty strong line? Like, really like to find a better example. Here we go. You see how in choices A and B, that data pretty clearly, you could draw a line through that that would be pretty close to all of those dots. And the line would have a negative slope. So we would say that those are negatively correlated, because the line that you could draw through the data in choice A and choice B is a line with the negative slope. Choice C, it's more of a curve. So that would be a little less correlated linearly. And in choice D, that's definitely not creating a line. So that's definitely not strongly correlated. So when I say correlated, one of the things it's going to ask you about is the R value, lowercase r. And again, this is why you've got to read section 12.6 and watch the videos there and look at the examples and look at the PowerPoint. But the R value tells you how strongly it's correlated. And the closer the R value is to 1 or -1, the more strongly the data is correlated. So if you have an R value of 1, that means you've got a perfect line. The data lines up perfectly on a line with a positive slope. And if you've got an R value of -1, all your data lines up perfectly on a line with a negative slope. If you've got a very low R value, like say 0.3, then that means your data, it still sort of makes a line, but it's not, that probably wasn't the best line to drop here. Let me draw some down here. Let's look at for example, this data, you see the line that they drew through this data? It's not perfectly through all of the dots. There are dots surrounding the line, but you can see that there's somewhat of a linear correlation, but that correlation is definitely negative because the line that you drew has a negative slope. So to say that there's a strong positive correlation would be false. Here we go. This is what I was trying to show you. Which one of these graphs would have an R value of 0.3? Okay, so in A, that's a pretty decent line. I would say the R value would be closer to 1 in choice A. In choice B, if you drew a line through that, that would be a negatively sloped line, so R would be negative. Well, it's not B. In choice C, that's also pretty close to a perfect line, so R is going to be closer to 1. Choice D, that could definitely be it, because you've got data that is making, you could sort of draw a line through it, but a lot of the data is going to be both above and below that line, and it has a positive slope. With E, most of the data is going to be on the line, so I'd say that's too close of a correlation. The R value would be closer to 1. And with F, if you drew a line through that data, it would definitely have a negative slope, so the R value would be negative. So D would definitely be the right choice for this question. Okay, same thing here. This is negative 0.3. So A is a really good fit for a line. It's a negative slope, so A would be closer to R equals -1, because the line would fit the data really well. We're looking for something that's going to have a negative slope, but that's going to have dots all around and surrounding and above and below the line, and that looks like that's choice F. So finally, we're getting to what you really need for section 12.6, which is how do I get this data into my calculator and find the value of R? Okay, so definitely the most asked question for this week's material. So how do I get this data into my calculator and get my correlation coefficient? So the first step, and you probably are going to want to write down each step. You're going to click, but I also have this on my website. I have a video on my website for this chapter, chapter 7 help, that I posted in the announcements, and I will post it again in the analysis to remind everybody. But each chapter has a frequently asked questions page. So I have a video of this, and I also have a PDF of this, depending on which type of instructions you prefer. So you click on the STAT button, S-T-A-T, which is right here below the delete key. So you click on STAT. And then go to Edit and hit Enter. You might have some data here, and you might not have any data here. This might be empty. But because you'll be using this for your homework and for your quiz, it's important to know how to properly delete all this data. So if you use your arrow key to go up to where it says L1, you want to hit the clear button and then the down arrow. That gets rid of everything. You do not want to hit the delete key, because that will completely delete list 1. You don't want to delete list 1. You want to keep list 1, but you want to clear all of the data out. Now, there's an easy way to get your list back if you accidentally delete them. Just email me and I can tell you how to do that. So if you go up to list 2, clear, and then arrow down, that deletes everything out of list 2, and then now we've got those empty and we can type in our data. So first, for list 1, we're going to type in all of our X values. So look at the data that's given and type in all of the X values in list 1. As you type in each number, you just hit the down arrow. And then for list 2, you type in all of your Y values. So as you type in each number, just keep hitting the down arrow. It's really important to double check that you have entered every number correctly, because if one number is off, even by a little bit, you're going to get the wrong R value. So just double check every time, maybe probably triple check that you've got all your X values correct in list 1 and all of your Y values correct in list 2. Okay, so now that you have that, you go to stat again, the STAT key. And this time you use your arrow to move over to calc. And you move down to the one that says LINREG. That stands for linear regression. So we're creating a linear regression line. And you hit enter. Now, when you hit enter, if you have a TI-83, it's just going to pop up with the answer. And so you're good. If you have a TI-84, you're going to see this screen. And so you just want to make sure that for the X list, it's L1, and for the Y list, it's L2. That just means where did you put your X values and where did you put your Y values? So for the X list, if it doesn't say L1 for some reason, you can just hit the second key and the number 1, and that'll put L1 there. And the second key and the number 2 will put L2 there. You don't need to have anything where it says frequency list or store REG. You don't need anything there. And then you just hit enter. And just like magic, there it is. So that gives you your R value. And be sure to pay attention as to whether it's negative or positive. So we have an R value that is negative 0.95229, and on and on and on. And it
When
says,
excuse me, when I did that, I didn't get the R values. I got the A and the B,
okay,
but the R didn't come up on my calculator.
that is a common issue. So let me show you how to fix that. So before I move to that, just note that this says around to 3 decimal places. So for R value, we would just say R is negative 0.952 for this particular question. So negative 0.952. So if for any reason, because this happens to a lot of people, if the R doesn't show up on your screen and you only get the A and the B, here's what you do. You go to the second key, second, and then catalog, which is just above the number 0. So if you hit second catalog or second and the number 0, you're going to scroll down until you see where it says diagnostic on.
You said to hit second and then what to get to catalog?
The number 0.
Okay, I
So,
see.
okay. And so after you hit second 0, you'll just scroll and scroll and scroll and scroll until it's in alphabetical order. So you'll get to where it says diagnostic on.
Okay.
And then hit enter. And then hit enter again. So you're going to hit enter twice. And on your screen, it should say done. So say diagnostic on done. Now, the next time you try to ask it to do that linear regression, your R will show up. So when you go to stat calc, linreg, and then hit calculate, it should be there. Okay. So those are the most asked questions about this week's work. Again, keep these shapes in mind for section 7.6 because that's a huge part of where people get confused. Email me if you've got questions. Don't forget about my chapter 7 website. Let me kind of show us a sneak peek of that just to remind everybody. I cannot type. Okay. So my chapter 7 website, we have we have a break-even point question, we have a cost revenue question worked out. We've got how to use E on your calculator, how to graph scatter plots in MyLab Math. We've got the bar graph, that bar graph question that I worked out. And then we've got a video and a PDF of entering data and finding the linear regression for section 12.6. And so if you come across anything else that I didn't do, anything you've got questions about and is not on here, please email me. I'll add it to this page. I'll add an explanation. I will, get you the answers you need and, make sure that you get it done early so that you can ask questions before everything is due. And so just let me know if you need any help at all with any of that. Does anybody else that's still here, and thanks to everybody who came, does anybody else who's still here have a specific question that I didn't work through that they'd like to see done? Okay, I'll take that as a no, not yet. But like I said, don't hesitate to email me with anything. I will get back to you as soon as I can. And I hope you guys have a great day. I hope this helped. And I hope that, if you haven't done some of these questions yet, I hope that when you get to them, you'll be able to go back and look at these notes or this recording. Hopefully, fingers crossed.
Yeah, for sure I'll be watching it again.
Okay. And yeah, but just, anything that I might have left out that you need help with, just make sure you email me and I'll be here.
Thank you so much.
Thank you.
You're welcome. Thanks. Have a great day.
You too.